So now we're going to talk about series capacitors really quick. I have two 1000 microfarad capacitors here in series. It's very important that they're equal value. So one thing to be aware of, whatever the supply voltage is across it, they're going to divide up that voltage. You definitely want them to be equal value, so they divide up those voltages equally. And you'll get 5 volts on each of them if you charge the two of them in series to 10 volts. The problem is that they don't have to be balanced. They could become completely unbalanced. Maybe you accidentally short-circuited this one right there, or maybe it's not very good. The dielectric in the middle of the two plates, maybe it leaks current through it, and at some point the upper capacitor is going to become fully charged to the supply voltage, and this one's going to be fully discharged to the supply voltage. That's a worst case scenario, but it can happen. And it can be vice versa, the other ones. So you can have anything in between these two values as long as they add up to the supply voltage, about 10 volts right there. So one way you can, reduce the risk of that, it's not perfect, but just take a couple of, in this case, 100,000 ohm resistors. That value doesn't really matter. The lower the values, the more it will maintain a balance between the two, but also you'll have more waste current right there. But if one's got a higher voltage, it can self-discharge a little bit and allow the other one to charge up a little bit more or whatever until they're the same voltage. So we will grab the multimeter and look at that. So now there's another thing that I have to mention. We're going to measure the capacitance, because when you put capacitors in series I should say, you actually get less capacitance, and they should be equal value. And so now these two ends of the capacitors are not connected to anything. They come to a dead end because I removed the power supply, which was off, but it wasn't a dead end because it was still part of the circuit, even though it was off. But in case, we can go across the two capacitors right there and wait a bit. It's auto ranging, takes a little bit of time, but there you can see we have about 500 microfarad approximately across the two capacitors. If I just come to one capacitor, measure across it, again it's auto ranging. It takes a little bit of time to pop up on the display. About 1000 microfarad, not perfect. And then the other one is about 1000 microfarad. Won't be perfect either right there, but close enough to 1000 microfarad. So that's actually millifarad, 1/1000th of a farad. 1 millifarad is 1000 microfarad. So be aware of that. It's always important that you understand that math. And actually I need this meter, so I'm going to put it back. I'm going to turn it off. I could just set it to voltage, but I'm going to reattach the supply voltage right there. So instead of pressing on the circuit with the probes, I am going to take my alligator clip. So I crimped them just with a pair of pliers to the other end of this male-to-male jumper right there. So first we're going to look at the supply rail. The power supply is off right now, but I'm going to plug that jumper into the negative rail. And then the red one right there into the positive rail right there. So we see the voltage across the two capacitors. Power is off. So this power supply actually provides a slight negative voltage right there. And so now I'm going to turn the power supply on. And you can see we charged up to 10 volts right there. Now the negative voltage was low enough, I don't think it would damage anything. Plus we're going to purposely make it even worse. But in any case, that's across the two capacitors right there. But it's 5 volts each. So this meter, I think, when you measure voltage, has about 10 million ohms of resistance. So this capacitor is going to discharge through the meter, and it's going to go down. That one's going to go up over time, but very, very slow, as you can see there. In any case, it's about 5 volts, a little less than 5 volts. So the one up here is a little more than 5 volts. And we'll see that right there. So I'm guessing this one had the slightly lower capacitance right there. The one with the lower capacitance will build up the slightly bigger voltage. So that's one problem. Now, we're going to do another thing where we do kind of the worst case scenario, for just like a regular circuit, if the capacitors are fine, is discharging one of the capacitors. Now it's important, it's going to stay 0 volts if I turn the power off with that jumper there. So I'm going to plug the jumper. Again, the meter has about 10 million ohms of resistance, I believe, while measuring voltage, if I remember right. But yeah, there you can see we got about 0 volts. Now, when I remove power, voltage is going to go down. We're going to get about a negative 5 volts. And actually, this power supply doesn't discharge the capacitors instantly. Even though it provides a slight negative voltage when it's off, current will trickle into the power supply. But yeah, it's going to level off at about negative 5 volts or whatever for that capacitor. And then the lower one is going to be about a positive 5 volts. And actually, I hit the power supply, so I hope I didn't do something wrong. But there you can see. Again, it's going to go down. They're kind of equalizing a little bit. But in any case, there you can see. That one has the positive voltage. This one a negative, which is really bad because these are polarized capacitors. So I'm going to turn the power back on so that, you know, it's showing 0 volts now. But the other one is about 10 volts. So, as I showed before, we could take 100,000 ohm resistors and balance them, but we have a little problem where they are really unbalanced, and I kind of hid those resistors. There we go. There's the other one. So what I'm going to do is take one of them and put it across the one to the positive supply. So again, that's going to help make sure it's discharged, but we already, you know, did that already. And now the other resistor right there. And now they should be pretty well balanced. I'll sneak in the back right there. And that spot right there. So yeah, that one is 0. This is not a 220 ohm resistor. That was the problem. That was throwing it off. There we go. Let's grab a 220, and this will quickly balance them. So, oh, this jumper is not to the negative supply. That's why I wasn't getting a reading at all. There we go. So we got 5 volts, and of course the upper one is going to be 5 volts. So it really quickly, since this is relatively low resistance, we'll get it to about 5 volts each right there, and hold it really steady. So now I'm going to turn the power supply off, and with these 2 resistors there, you can see we need a little bit more than 20 milliamps of current, so I need this at least about 0.3. So we're going to turn that off, and that'll make sure they stay a lot better balanced. But we can take the 100,000, and I believe I am way off right there. There we go. Go up there, and then this 100,000. So if I turn the power on now, they're going to become unequal because I just have the 100,000 ohm resistor. But you can see it changes, but it changes it slowly. So there we go. I plugged it in there. Now it's going to do probably a pretty good job getting them balanced at some point right there. Slowly getting them more and more balanced, because it is 100,000 ohms. So not super quick at discharging one while letting the other one charge. But over time it will. So this will help keep them balanced right there. So in any case, yeah, that is really about it. So I'm going to turn the meter off. We're all done with that. And you know, these are fairly balanced. This does provide a slight negative voltage, but you know, when it's off right there, slight negative voltage, but not too bad as we saw before. And then I'll remove the probes right there. But otherwise, that's really about it. Get the meter out of the way. Just as a review, what you're looking at here, we got them in parallel, and in series, I mean. We have 2 of them in series. These capacitors can be charged up to 35 volts each. So with the 2 of them in series, they got half of the supply voltage. As long as they stay balanced, that means we can get one to 35, the other one to 35, for a total of 70 volts. We could apply 70 volts, and these would be pretty safe. Of course, that's the maximum voltage they can be charged to, so that might be pushing its limits as well. You definitely don't want to go above a capacitor's maximum voltage. It really is like a maximum voltage. You could damage it. You should stay a bit below it probably. But yeah, we could, safely, for the most part, get 70 volts across the two of them in series, but not one of them. And again, I showed that we have capacitance cut in half. So the reason why is because when you start charging these two capacitors, the same current going into one capacitor is going into the other capacitor. So they are both charging up with that current going, as if they were alone. So that's why they have the lower voltages. One is raising its voltage, the other one's raising its voltage at the same time until they meet that 10 volts. But each of them needs half the current that they would have needed to get 10 volts on their own right there. So ultimately, the voltage is going up twice as fast for a given current. Thus, they have half the capacitance or whatever. And worst case scenario, one could be completely charged and the other one completely discharged. I used a jumper to discharge one capacitor, but it could actually be leakage through the capacitor. So the resistors, they kind of overcome that problem. So if this one has like a little bit of leakage, that one wants to charge up, but it will also kind of discharge, and also current will be more likely to go this way right there when this has a higher voltage right there. It'll pass through that way, and also through the two resistors. You always have waste current in this setup right there, but maybe it's more beneficial to have that waste current than unbalanced capacitors. This is not something you'll actually see a lot just with regular capacitors like this. More likely for super capacitors, because you can't charge them up to as high of a voltage. Not even, I do have 5 volt super capacitors, but there's two capacitors built into it that makes it 5 volts. Each one of them is, I think they're 5.5 volts. Each one of the capacitors inside the capacitor can be charged to 2.7 volts. And so they put 2 of them in series, and maybe it's 2.5 volts. But you put them in series, then they add up, but that's internal to it. And I don't know how they protect them other than that. Hopefully they got like balancing in there, but for the most part, capacitors should stay pretty balanced, but you can add balancing. In this case, resistors right there. Not the best solution, but a simple one. So in any case, this went on much longer than I thought it would, but I hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.